on the recording. I got feedback from a student in another class that it kept telling her the meeting was being recorded, and I actually think it was her internet was cutting in and out, and that's why she was constantly getting that message. All right. Okay, so I want to go ahead and share my other screen. Okay, and I need to open this up. The social dilemma assignment, I believe that is posted. I think I gave you like 3 weeks on it. So you really should focus right now on the, sorry, I'm thinking and looking at the same time. Right now you should be focusing on getting yourself prepared and ready for the exam. Okay, so today my goal is to finish 14.1. I will back up just a little bit. Yeah, project 1 is due on the 3rd. I can push that back till the 4th. You know, or we can move project 1 till after the exam. Would that work better? Okay, so I'll make a note. We'll have project 1 due the week after the exam. Okay, so let me share this screen here. All right, here we go. Yeah, let's just focus on the exam. And I want to get the chat open. Yeah, let's focus on the exam, and we will have your 14.1 assignment then due after the exam is complete. Or not 14.1, your project 1. So let me make a note of that, and then let's talk about the exam. So let's go ahead and let's make project 1 due, your exam's the 7th. Let's go ahead and make it due October, I don't know, I guess we can push it out till October 18th. Okay, but let's not delay it any further than that. All right, so as I said, I am looking forward to lecturing on 14.1 today, but based on the request to back up, let's back up a little bit. And to start, let's sort of talk about what's going to go on with the exam, so you can plan accordingly. Okay, if you need to get off work, or you need to tell your supervisor you're not available that day, or whatever you need to do. Okay, for some reason I have the draw function on, and I don't want the draw function on. I want to close this completely, and I want to draw using, there we go, using the smartboard. Okay. So the first exam, it's going to open 10-7. It will open at midnight, so 12 o'clock a.m. I will lecture on 10-7. Okay, I may need that time to give you some newer material. My goal is that I don't, but we'll see. We'll see how that goes, but do plan to be into lecture that day. The exam will then be open until, and let's look at this, 7th, 8th, 9th, the 10th at midnight. All right, so you will have then until 10-10, and it will then close at 11:59 p.m. All right, so hopefully that gives you some time to plan your life accordingly. If you have family at home, maybe you talk to your family and they all go to a park or something so you can sit and take your exam. All right? Okay. The exam is 15 questions long at this point. Now, I might be having to eliminate some questions. If we don't get far enough for you to be able to take the exam on this, then I'll make arrangements. Otherwise, 4.1 and 2, 4.3 is going to go really quick, in my opinion. It's not a difficult concept. I might have to pull 4.4. The exam covers all right, the exam covers from the beginning of class, which is 12.1, through 14.4. And I'll put a question mark next to this. My rule of thumb, if I don't get a chance to lecture on it and you don't get a chance to work on it, I don't typically put it on exams. So 14.4 or 14.3, those might have to be pulled off the exams. All right. You will be allowed 4 hours to take the exam. You are required to upload written work. Okay, so what my rule of thumb with this is, you know, because we're not in a classroom, in order to help me maintain integrity of this exam, I require you to upload written work. If you have a problem, even if the answer is right and you did no work for it, you get 0 points for it. Okay, so that's how that is going to, that's how that's going to run. Let me think. One of the things you're going to need to be comfortable with that's a pre-calculus topic is completing the square. So that 4 hours includes you taking the exam and submitting the work. So if you started at 2 o'clock in the afternoon, you have till 6 o'clock that evening to complete the exam and submit the work. Now, you do need to do the exam in one sitting, and it won't take you 4 hours, okay? But you need to do the exam in one sitting, no exceptions. You know, don't get up and wander around the room or leave. If you have a lot of stress and you need to sort of get that nervousness out, you know, I don't care if you're sitting there squeezing a stress ball, all right? I don't care if you're running your feet up and down at your chair, but you do. Now, I will sit down and take the exam, and let me write myself a note, and I'll let you know how long it took me to take it. The problems are not that long or that difficult compared to quizzes and homework. All right? Any other questions? By the way, and you guys are probably already done this between this spring, there are different apps out there. One of them is, Cam Scanner. That's one. I don't know, there's some other ones out there. They're free. You will need to submit your work as a PDF. And even though it's technically considered scratch work, oh, Genius Scan is another one. Thank you. For some reason, I was thinking Google Scan. Genius Scan. All right. iScanner. All right, that's another one. Whatever works out best for you. I do need it as a PDF. Please label your problems.
I have a quick question, Dr. Mankey. I am wondering because you're saying that they're, considerably easier than the homework and quiz problems through WebAssign, but that practice exam on WebAssign should, is still going to be a good idea of, are you making these problems yourself or are they generated through WebAssign?
They're not generated, they're kind of pre-generated, so to speak. But they're very similar to the review exam, which is in WebAssign. No, you can use a TI Inspire calculator if you would like, Francisco. I don't set up calculator limits, especially for Calc 3. I know some of them can integrate for you and stuff, and that's why I require you to show me the work. All right, so you're gonna have to, even if your calculator spits out an answer, you're gonna have to show me the work for that.
I have a question.
Okay, I hear someone talking, but it's really, really slight. You need to speak up a little louder. And I do have the hearing aids turned all the way up. Go ahead.
So I noticed that you have like a template for the exam that says question 1. Should we print out those or do we just write it on our paper?
No, you don't have anything you have to worry about printing out.
Okay, and also when we submit the work, do you want us to get out of the lockdown browser and then submit the work?
Right, you would finish inside the lockdown browser and then submit the work. Okay, and yes, you do get a formula sheet. I will email you out the formula sheet. You will need to either write it out or print it out and then show that to the camera before you start. By Monday, I can try to get it out earlier. Just depends on what other stuff pops up. Okay, so there's still some confusion with regard to our normal and our tangent vectors. Oopsie, so 13.4. The quiz was a little ugly. Now, I know what happened is we lost the forest between the trees, and unfortunately, instead of focusing on what was happening with that, you guys were, for lack of a better term, pushing back. So let's go ahead. I guess the length of the curve is okay. Let's look at the normal and the tangent vector. I'm looking for a problem that's going to fall out pretty nice. Okay, so let's go ahead and first off, I'm just going to sketch it in 2D. I do not have 3D talent. All right, but we have a curve, all right, and we have a point on the curve, right? The tangent vector is going to be tangent to the curve. It's always been tangent to the curve. It was tangent to the curve back in Calc 1. So that's not going to change. Your normal vector is then going to be 90 degrees off of your tangent vector. Okay, and so that's how you can think of them. So this is your tangent vector and this is your normal vector. All right, so let's go ahead then, and you need 2 things to be able to pull this off. All right, so let's go. The first thing you need is you need a vector, Okay, and remember this R vector, and maybe this would also help. You have spent years determining these curves based on equations, and a lot of times with equations, but you can also determine that point based on a vector. Okay, and that's your parametric equations. All right, so R is then, let's go ahead and set up a vector. And let's go ahead and do a point. All right, now when we find these particular vectors, the first one we need to figure out is the, well, doesn't have to be the first one, but one of them that we can figure out is the tangent vector. Right, and so the tangent vector is then the derivative divided then by the magnitude of the derivative. I usually call it a tangent unit vector, okay? Your book, WebAssign, these authors, Stewart refers to it as a tangent vector. The reason I call it a tangent unit vector is because you've been doing this for years. In order to find the tangent line of an equation, right, and to get the slope, you took a derivative, okay, and then you plugged your point in, and that gave you your slope. Okay, so our tangent vector, we're going to take the derivative, except it's really the tangent unit vector, because we're going to divide then by the magnitude. That's a unit vector. All right, so if we take the derivative of this, this is going to be 1, 2t, 3t squared. All right, so that's going to then give us what? If we're looking at a particular point, so to speak, we can get the magnitude then, right? If we look at R, let's go ahead then and look at the magnitude of R, right? That's going to be then the square root of 1 squared plus 2t quantity squared plus 3t squared squared. All right, so we're going to end up then with a tangent vector. This is going to be 1, 2t, 3t squared. All right. We use the same notation, it doesn't matter. All right, over the square root, this is then going to be 4t squared plus, this is then going to be 9t to the 4th plus 1. All right, it would be nice if that was a perfect square, but I don't think it is because we've got that 1 hanging out. All right. Now at this point, right, we could figure out exactly what was going on at a single point, but let's go ahead then and let's find the normal vector because that's what the original question was. The normal vector is then the derivative of the tangent vector, okay, over the magnitude of the derivative of the tangent vector. Okay, so now you're going to need to go back to this whole thing, which seems to cause problems, but this whole thing you need to go back to and take the derivative of. I'm not going to do any simplification, we're just going to go for it. Now, if you look at it, what rule are we going to have to use on this, right? Well, we can think of it that we're going to either have to use quotient rule or product rule in order to find the derivative. All right, so let's go ahead and write this out. So this is then 1 plus 4t squared plus 9t to the fourth. This is all then raised to the negative 1/2. This is 1, 2t, 3t squared. Okay, now what we can do with this is we can go ahead and we can take, I'm going to use product rule first, and I don't care what rule you use. Oh, I lost a t and made it a 94. Right? And then I'm going to take the derivative of the second. So this is going to be a 0. This is going to be a 2. This is going to be a 6t. Plus the second, which is 1, 2t, 3t squared, times the derivative of the first. I don't have nearly enough room. Let me move this over. All right, so let's see. We're going to need to use a chain rule in here, so the negative 1/2 is going to come out front, right? This stays the same. This is then negative 3/2. And then we're going to multiply this by 8t plus 4 times 9, 36 t cubed. Okay, so that means we're going to end up with 0 to 6t over 1 plus 4t squared plus 9t to the fourth plus 1, 2t (3t squared) times 8t, oops, that's a close, 8t plus 36t cubed, all divided then by negative 2, this is kind of awkwardly written, 1 plus 4t squared plus 9t to the fourth, raised to the negative 3/2. Okay, so this got uglier than I anticipated, but this is how you would find your t prime.
Wouldn't it be to the positive 3/2?
Okay, you need to speak louder, please.
To the positive 3/2 since you dropped it.
Yes, it would be to the positive 3/2 since we dropped it. All right. The one on your exam is, that one I did look at, is a sine and cosine. And as you know, when you have a sine squared and cosine squareds, things drop out nicely. And I did that one for you in class. Okay.
Mikey, before you go on, I think perhaps you're answering someone else's question as well, but my confusion might be coming from the difference between doing this, finding the unit tangent vector and the normal vector of a position vector, and then in the next chapter, the tangential and normal components of acceleration. I think I kept on confusing the two.
So if we have an acceleration vector, right, and any vector, it doesn't matter where it is, you can then get your tangential vector by the derivative of the acceleration vector, right? And you can then get your normal vector by the derivative of the tangential vector.
Okay, yeah, so it's exactly the same thing.
Yeah, it is.
Wow, I don't know why the book makes it seem like it's something completely different.
No?
All right, that's better. Thank you.
Okay. Okay, yeah. No, it's just that. All right, so let's head into 14.1. Right, and we're starting to look at how we're going to deal with several variables. And I need to show you, there's a couple of things I wanted to do. All right. One of them is I want to show you how to pull stuff out of a table. The book's explanation wasn't great. Does that make more sense, Camilo? Okay. So, and once again, I'm always available for office hours. I should be available 9 to noon tomorrow. My husband is out of town, not that you guys care. That's okay. My husband is out of town, and so I'm on in-law babysitting duty, and they are 80 and 85. And my father-in-law just got diagnosed with shingles, so, but I can set up a computer at their house if necessary. They have in-home nursing care, but just in case, if there's something that happens, please be understanding. All right, now there's a problem I did not do, and let's come down. What we need to do is we need to start talking about graphing these guys up, not just the domain, but graphing them up completely. All right, so we talked about the contour map. The one I did not do, and we need to spend some time doing this, all right, is when we have a table. And let's talk about how we read the table. And this is going to come into play not only when you have actual data you're working with, but when we move forward in this chapter, we're going to use tables to find rates of change, all right? Just like you did back in Calc 1. So let's go ahead and we're going to look at a table. I believe this is the table in your homework. And I'm not going to write it all out. Okay. But let's write a few columns out, and we'll just work with the columns that we write out. I probably want to leave some more space here. In fact, I'm going to draw lines to keep myself on track. Okay, now let's talk about what this means and what's going on here. We actually don't experience this in Arizona. So this is kind of an unfair, I don't want to say unfair, but it's a problem that we're not used to. All right, so I want to go ahead and I want to talk about this problem since, as I said, it's a problem that we're not used to seeing. This here is temperature. All right, and it happens to be in degrees C. And this here is then wind chill. All right, and so this is in kilometers per hour. So what happens when you live in a cold place, if you've never been there, is there'll be the temperature outside, which might be bearable, but when the wind starts blowing, it just, I don't know, it cuts right through you. There's no other way to describe it, all right? And so you need to worry about the wind chill, all right? And one of the things that, when I was in college, I went to college in Colorado at Colorado School of Mines, and Golden wasn't too windy, but it was kind of bad enough that you wanted to make sure you had a coat that was like longer, which sounds really dorky, but the difference is then when you got to the classroom, it would sort of keep your legs a little warmer type scenario, okay? All right, and so let's talk about how to read this. What you're gonna see in your homework is you're gonna see a problem that looks something like, oh, let's try this. 5,15. All right, you're going to assume that the first column here is your sort of what we kind of consider your X value. So even though this is temperature in degrees C, we're going to label this as sort of our X's. And the wind chill then we're going to then identify as our Y's. So at 5:15, you would come here to 5 and 15. All right, so the wind chill or the temperature you are actually experiencing would then be 2. All right? All right, now this is a lot of times you'll hear this called the wind chill temperature, but it's the temperature you're actually experiencing. All right? If you don't have any wind blowing, then you experience whatever the temperature is outside. The wind's blowing, it's going to honestly feel colder. All right, so you guys let me know in the chat if I tell you I want to know about 0,20, right? And I'll scroll back up so you can see this. Let me know in the chat exactly what you're going to be experiencing. How cold is it going to be? What are you going to be experiencing? Good, good. Okay, you're going to read this as, you're going to look here at 0. All right, and then you're going to go over here and you're going to go down from 20. So your answer here is then going to be a -5. All right, so even though the actual temperature outside is 0, you're going to experience -5. Okay, so I wanted to make sure, I don't know why this wasn't in my notes. I know I've assigned these problems in the past, and I think your first 4 or 5 problems in WebAssign is this type of situation. The reason you're working on reading these charts, oh, let me back up. Okay, the other thing you're going to see at WebAssign before we leave this problem, if I tell you at f of -5 v, and I ask you what is happening, because you're going to see this type of scenario on the homework. All right, what you're going to do is you're going to isolate your -5 row. All right, so you'll notice, you'll see it's -7, -9, -11, -12. And you get these drop down buttons, but basically as your wind velocity increases, your temperature, wind chill temperature, we'll write it like that, decreases. Okay, so when everyone is working through their homework, okay, you're going to get questions that are like this. And the questions are, what's the trend? Now, why are you going to have this? Because ultimately what we're going to do is, just like back in Calc 1, I don't know, the problems I remember was a bicycle or something, and you were figuring out velocity based on time and position of a bicycle. That's a derivative. We're also going to do that here, where we might look at a derivative between 5, 10 and negative 5, 20. And what's the rate of change between those two? All right, so hopefully that helps somewhat. Okay. All right, the second half of your homework, half is kind of a rough word to use, but the second half of your homework then has to deal with graphing these as contours and then 3D. Okay, so let's go ahead then and talk about how that's going to work. All right, so I'm going to stop sharing just for a second so you can actually see me. All right, so I'm not a little tiny thing. Okay, so when we look at these contours, and I don't know if I made this clear last Wednesday, because honestly I was a little flustered. I didn't expect to lecture on 14.1. Right, we have, this isn't some strange gang sign, right? We have what? Let's do it this way because that's how we usually look at it. We have an X, a Y, and a Z, correct? All right, so that's what we're all looking at is an X, a Y, and a Z. When we look at a contour, it's like we're turning it and you're looking down the Z axis. So you're seeing what's happening on that XY plane. All right, and gosh, I forgot to bring it in this morning. Oh, you know what's in my office? A really good example is like a slinky. If you take a slinky and you pull it up, you guys don't know what those are, do you? Well, maybe you do. If you take a slinky and you pull it apart, right, and then you like offset it, okay, and then you just took a picture, a shadow of what's happening with that slinky. So you took shined a light on it, and you looked at the shadow, you would see the rings are all going to be there, but they're now flat because they're in that XY plane. When we have contour maps, all right, that's exactly what's happening, is we're taking some complicated curve and we're taking a shadow of it and putting it into an XY plane. You're going to see these a lot. All right, so let's go ahead and start looking at how to do these. And I'm going to write some steps out for you on how to do contour maps. Okay. Okay. So we talked about this one. Now, if this was a table, right? If this was a table, the table would look like what? All right, we would have negative 30 here. We would then have, I don't know, negative 31.5 here, and then this would be 283.8. Okay, so if we were looking at a table, that's the type of scenario we would see. Okay, so the table and the contour map are kind of interchangeable. The question is, how do we move from an equation into a contour map, or even into the table to develop a contour map? All right, so let's talk about doing that. And by the way, all right, you'll notice on this contour map, because we're going to have to do slopes of contour maps, right? What is happening if I'm a little person and I'm hiking up this, right? I am gaining elevation as I am hiking up that. Right, so let's look then, and I don't think we got a chance to look at this, right? This is then what's happening. So I think mountain range and hiking maps are one of the ones you're most experienced with. You will see these where these are temperature gradients. Okay, and so this is a similar type scenario. Okay, notice we have, I don't know how well you can see it, but let's say 1400 is here, and then we have, I guess I'll just color it in. 1400 is here and there. All right. 1100, let's skip over to this one. 1100 is running here, and then 1100 is going to be down here. All right, so those numbers that are on those lines tell you the height. The numbers gives you, for lack of a better term, the numbers is then your Z information. Okay? So that's what's happening. All right, so let's talk now about drawing these contour level maps. Okay, because we didn't get a chance to do that. By the way, those of you that have started the 14.1 homework, don't know, I should have asked that as a Minty slide. How are we doing? Okay. All right. If you haven't started it, don't wait till Sunday night. All right. I go to bed early. Okay, so let's talk about drawing these contour level maps. Right. And I have other faculty members that criticize for me for this, but I like to give you a recipe. Hopefully from the recipe you can then, I don't know, see where to go with these problems, because I do think you need to start at least with a map. So to draw these contours or these level curves. Now, remember, a contour map, if it's asking for a contour map, it wants a map that's in the XY plane. Okay, there is, by the way, I think I linked one of them, but there is a lot of graphing programs you can do that do give you the 3D graphing. And so if you want to work with graphing it in 3D when you do your homework and you want to use a computer, that's fine, but I would encourage you to draw your contours by hand. So your first step is you're going to say f of x comma y equals z equals. Okay, now if you remember the map I just had up a few minutes ago, it was what? It was just a series of numbers. So we're going to set this then equal to a constant, and it doesn't matter if you use k or c. All right, now by the way, I got a question about this. All right, so this is sort of a side note. The author was using C vector, meaning a constant vector. I was splitting it, C sub I, C sub j, C sub k, all right? Because we were working with vectors. That's all I was doing there, all right? In this scenario though, we are not working with vectors. Okay, so what do we end up with? We then end up with a k or a constant, right? It is then going to equal an equation. At this point then, you're going to want to manipulate it. And I know this seems a little strange to some of you. Those of you that are taking DiffyQ, y'all are already on the page with this, that what happens is you're working through something, you just get, I mean, you make it look like you want it to look, right? And you manipulate it, and there are shapes we know what they look like, all right? The big one you're going to be working with is what? We have circles, right? We have ellipses, and we have hyperbolas. Don't know if you see any hyperbola shapes. All right, So you might need to manipulate it. Sometimes that also doesn't work. All right, and when it doesn't work, what you need to do, and students don't like to do this, but choose K. Find X and Y. Okay? All right, so you're going to pick your own Ks. Now, there's always, I don't know, students back in college algebra, or not even college algebra, intermediate algebra, get frustrated. They don't understand. They're like, what do you mean I can pick any X that I want to pick? Why did you pick those X's? All right, and I pick the X's I want to pick because I'm lazy, because I want the math to be easy. All right, I don't want to be dealing with some weird, funky fraction decimal thing. But it's the same thing for K. All right, pick what makes sense. All right, so let's go ahead and look at a problem. I don't know where that problem is. Not gonna worry about it. All right, so let's go ahead and we're going to graph the contour. Now, in your homework, this is multiple choice. All right. I believe it's multiple choice on the exam too, but you're going to have to show me the work on how you graph your contour. So I'm going to give you, right, an equation. And so let's go ahead. I'm going to say this is z squared equals x squared plus y squared. All right, in this case, I don't have to isolate z. It's already isolated for me. So I'm in okay shape there. But what do I need to do? I do need to take a square root. All right. Now, once I have z as a single term that's isolated by itself, we're going to just say, you know what? What's happening along that z-axis as we're building this thing? What's happening to it? It's becoming what? It's just becoming a constant, right? Because those contour curves just give us a constant. So we're going to reformulate this as then k. All right, so now at this point, let's identify. If I put this back as a square, yes, of course it will. All right, if I put this back as a square, just assume everything's going to be on the exam, and then you'll be in good shape. All right, so that looks like what? Let me know in the graph. What does that look like? Nice, Hannah. You guys agree with her? That looks like a circle, correct? All right, so it looks like a circle. So if we choose K, right? By the way, the circle's going to have an origin where? The origin, my circle, is going to be at 0, 0. Because there's nothing else going on with this, is there? If I choose K to be 1, right, then x squared plus y squared equals 1. If I choose K to be 2, then x squared plus y squared is then going to equal 4. Would you agree? So it has a radius of 2 for my circle, doesn't it? We'll put one more down. If I choose 3, then my x squared plus y squared is then going to equal 9. So these are circles with different radiuses, okay? as k get bigger, does my radius get bigger or smaller? Let me know in the chat. Good. Yes, it does. It gets bigger. All right. All right, so let's talk about what's going on here. Right? We're always going to be at our origin, but then if we think about it, right, we're going to have a circle here. And so this would then be at k equals 1. At k equals 2, right, we're going to then have a bigger circle. That doesn't look right. Right, at k equals 3, we're even going to have even a bigger circle, aren't we? All right, the outside of this then is going to look an awful lot like a parabola. Oh, I didn't graph the contour. I graphed the 3D. I skipped on you. All right, so let's just look at it from a 2D scenario. Right, so here is my k equals 1. Here is my k equals 2. Here is my k equals 3. All right, so that would be what my contour looks like. Now, just like we pull and stretch a slinky, this is just a slinky and that has different, instead of all the slinky hoops being the same, they're smaller and then they get bigger, which is what I was sketching here. It's going to look like this. All right, it is a conical slinky. Now, we do have to be careful because in order to solve for z, this gave us an idea of what was going on, but in order to solve for z, what did I have to do? What is in front of that square root? Well, it's a plus or minus, which means what? It's not only going to be up on top, it's going to be on the bottom. All right, because it's a plus or minus, all right, our k's can also be negative, can't they? So we're going to get this happening down here. All right, that would be along the negative z axis. All right, how are we doing with this? Please let me know in the chat. Okay. All right. Let's look at another one. Okay, so we want a contour map again. And we're going to start off this time with it looking like this. Okay, first step. We're going to take that f of x and we're going to rewrite it as our z. Then we're going to turn our frz into a constant k. All right, this one now, believe it or not, is a little trickier. That x squared plus y squared, that makes me think of a circle. All right, so we have k times x squared plus y squared equals y. All right, if I divide both sides by k, what do we end up with? Well, I end up with then an x squared plus y squared, right? I'm going to move this over. Minus y over k equals 0. Now, not quite looking like a circle. How can I make it look like a circle? What did I warn you you need to be able to do on the exam? Complete the square. So we're going to complete the square on this one. I'm going to look at this term here to complete the square. It's 1 over k, and I basically divide by 2 or multiply by 1/2. So I have 1 over 2k, all right, and then I need to square it. And when I square it, it's going to go on both sides. So we get x squared plus y squared minus y over k plus 1 over 2k squared equals 1 over 2k squared. All right, so now what are we dealing with? Well, let's look it out. Let's go ahead and write it out. It's going to be then y minus 1 over 2k quantity squared equals 1 over 2k squared. Are we now back to a circle again? We're at a circle where we are dealing with a 0, right? This center is going to be at 0. This one is then going to be at 1 over 2k, and a radius is 1 over 2k. Yes, k is a constant, and that's why we're able to complete the square. And that was one of the reasons why I wanted to show you this. All right, let's go ahead and look at what the contour map for this one is going to look like. All right, so I'm going to go ahead and I'm going to make a chart. Right, we have k, and by the way, right, we know if we think about, well, we're going to have an x squared plus y squared. Let's not write it that way. We can think of it this way. In back, we were using what? We were using h and k, I believe. So we're going to call this h, this k, and this r. All right, because it is a circle. Now, as I mentioned, I can choose anything I want for k, except what? I better not choose 0. All right, because then we're going to have something weird going on. Because I am lazy, right, I'm going to choose 1/2 for k. My h is going to be at 0, but then my k is at 1. I chose 1/2 because, you know, when you're dividing, you multiply column, you flip it. Okay. My r is then also going to be 1. Okay, why 2 k's? Because when we manipulated the equation, k ended up in 2 places, and that's okay, right? Because we're just randomly choosing what k is. One of those k's, this h is always going to be 0. Oh, I'm sorry, now I understand what you're asking about. We'll make this one look like this. because the center of a circle, that's what I'm trying to show you, is h comma, and we'll make it a little k. Does that help? 1k is my constant. I probably should have made it a c or something else. The other k is from the center of the circle. I think that's what you're asking. All right. If this is then 1/4, my constant is 1/4. This is going to be 0. All right, so we're then going to have, this is going to be 2, right? Yeah, that's then going to be 2. All right, and so my radius on this is also going to be a 2. If, for example, we do 1/6, this is 0. This is then going to be 3, and the radius on this is going to be 3. So as you're moving in, this is going to be like a triangle looking thing, isn't it? Because as you're moving in towards that XY plane, what's going to happen? As you're moving towards the XY plane, it's getting wider and wider and wider. So these are my center points for my circle. So our contour map, all right, if we are at, we're at 1 on the y-axis, right, then we're going to end up with a radius of 1. Our next one is 2 on the y-axis, right, and we're going to then have a radius of 2. All right, our next one is then 3, all right, and so 5, 6, right, we're then going to have something that looks like, oops, it's not going to go below the axis. Well, let's just undo. Let's try that again. All right, and so this would be the type of contour map we are looking at. Okay. All right, I'd like to look at an application problem, and then I really need to move into 14.2. I actually had some group work set up for you today, but that's okay. All right, so.
Are we going to be asked for these contour maps in 2D or 3D?
Contour maps are only in 2D. They don't exist in 3D.
Okay.
All right. So let's look at a homework problem. I'm using the wrong mouse on the wrong screen. There we go. Okay. So as I mentioned, all right, unless you're an avid hiker, you're not going to look at these topographic maps very often, right? But if where you are going to see this is as temperature. So there's a lot of times you're going to see contour maps where they are describing temperature. All right, so let's go ahead and do a temperature problem. All right, so we have a thin metal plate. All right, and we're going to have it located in the XY plane. Okay, and we want to sketch, and I'm not sure what words the book uses now. Here I'm seeing level curves. All right, the other thing is I've been calling it a contour map. Let's talk about what this really is. These are really your isothermals. All right, and we're given this function. All right. Okay, this might seem like kind of an esoteric problem. I can assure you, when you're an astronaut on the space shuttle, it's not an esoteric problem, right? You kept hearing about the tiles, always worrying about the tiles, right? We lost this many tiles. Are all the tiles intact? Wait, we hit something. We got to look at the tiles. If you look back, talk to your parents. Back in the 80s, whenever they sent the space shuttle up, that was the big worry. And the worry was because the tiles would fall off all the time. But it was also because you had those tiles, and they allowed then for the isothermals that you didn't, it was cool on one side of the tile, whereas you could hold a blowtorch to the other side of the tile, okay? This is a thin middle plate, so we're not worried about thickness affecting it. Typically, thickness does affect it as well, but we're not gonna worry about this at this point. So we're gonna walk through this just like we've walked through the other ones. All right, first step is we're going to say, I'm going to rewrite that t as a z. All right. Second step, we're in the xy plane, so we're going to make the c then equal to a k. All right. Now, what do we need to do here? We need to manipulate the equation, correct? So let's go ahead and do that. I'm going to move this stuff all over to this side. So I'm going to have k times 1 plus x squared plus 2y squared equals 100. All right. There's a couple of ways we can do this. I'm distributing out the k to the 1 so I can move it over. And then we need to divide by our k. So we end up with x squared plus y squared equals 100 minus our constant divided by our constant. Okay? All right. So tell me in the chat. By the way, we've got a 2 in front of that y squared, so that might cause some issues. So let's go ahead and divide everything through by 2. So that gives me an x squared over 2 plus, I'm going to write it this way, 100 minus k divided by 2k. Okay, folks, what does that look like to you? When I draw my contour map, what does that look like to you? Fabulous, you got it, it's an ellipse. All right, so let's go ahead then, and we know this is an ellipse, okay? We know the major axis, the long part's gonna be under the x, correct? Okay, so let's go ahead then and see what's gonna happen. All right, we're gonna put in our k's. Let's put in k as being 20. So this here is then gonna become, k is 20, let's see, that's gonna be 80 divided by 40, right? So we're gonna end up then with x squared over 2 plus y squared over 1. Hang on, math in my head just failed me. If I've got 80 divided by 40, we're gonna end up with a 2 there. Did I do that right, folks? Y'all are just, you're not talking to me. You're like, oh, we're just going to leave her stranded. Okay.
You did
So-
it right.
Thank you. So that ends up being a 2, all right? If I divide through by the 2, because if it's with an ellipse, it always equals 1, right? So now I have my major and my minor axis for my first ellipse. Let's do another one. Why don't we say what happens when k equals, oopsie, I didn't need to write it like that. Let's do k equals 40. Hang on, computer needs to catch up to me. Give it a minute. All of a sudden, a bunch of lines will appear. Or maybe not. Okay, great. So, might have to restart this guy. Not sure why he's doing this. All right, you guys plug in 40 and then let me know in the chat if you plug 40 in for k, what you end up with. All right. Yeah, he's going to need a restart. Okay. So, all right. So we end up with x squared over 2 plus y squared over 2 equals 3/4. All right. When you do that, what are you going to have to do? You're going to have to do what? We're going to have to flip it. All right. And so you're going to need to move that 3/4 to the other side. Exactly. All right. And that will then give you what is going on. So these are going to be a series of ellipses. Let me save this real quick. And maybe even by doing this, it might come back. Oh, yay. All right. So we then end up with x squared over 2 plus y squared over 1 equals 3/4. So we're going to divide both sides by 3/4. So we then end up with x squared over, oh, we made this 40, didn't we? Not 4. We end up with x squared over 6/4 plus y squared over 3/4. Okay. So our contour map is then going to look like what? All right, we're going to have 6/4. Let me back up. At 20, we were what? We were at 4 and 2. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2. So at 20, we have an ellipse that looks like this. All right, and that's then going to be what? That's going to be our isothermal temperature. So our temperature, 20-degree temperature, that's what the contour is going to look like. We're then
Sorry to
going to
interrupt. Shouldn't it be the square root of 4 and not just 4? Because it's in the ellipse formula, it's a squared, not just a.
Oh, yeah, I guess it should. I don't like it when technology doesn't work. I get nervous. All right, so then it's going to look like this. All right, so we now have, we need to take the square root of 6/4. That's going to be ugly. I don't have a calculator with me. What does it look like? Square root of 3/2. Square root of 3 is 1/2 divided by 2.75. All right, so then we'll have 1 here. Square root of 3.
I got 1.22.
Oh, it's going to be 1.22?
Yeah, that's what I got.
All right, and then the other one's going to be the 0.75, right? So 40, we're going to have something that looks like that. All right, so as we're getting closer to the heat source, what is happening? It's getting hotter. All right, so please hang with me. We didn't get a snack break today. All right. That wraps up 14.1. I'm going to go ahead and I'm going to start talking about 14.2 because I just don't want us to run too far behind. Because if we're too far behind, then I would really like us to be able to do a little bit of review before the exam. All right. Okay. So I'm going to start in on here. I'm not going to try to change slides on 14.2. And 14.2 has to deal with limits. Okay, and at least we can kind of do some review of Calc 1 limits. All right, so in Calc 1, right, if we had the limit as x approaches 2 of x squared plus 6x, let's say, right, you would say what? You would say, is there a domain problem, right? That was why in 4.1 we were talking about domain problems. So you would say to yourself, is there a domain problem? No domain problem, I can plug her in. Right? So hopefully this is ringing some bells and bringing some stuff back to you. We can also look at the limit as x approaches 3. So then we'll have x squared plus 6x plus 9 over x squared minus 9. All right, so this one we have a domain problem. Do you agree? How did we get out of this domain problem back in 220, Calc 1? Right? Okay, we used L'Hopital's rule, but I'll be honest with you, L'Hopital's rule isn't going to work in 3D. You can't, not going to happen. We're going to have to go back to basics. All right, Ethan, you're absolutely right. You could use L'Hopital's rule on this. Instead, what we're going to have to do, because when we're working in 3D, we're going to have to do this is we're going to have to go ahead and factor. Right, when we factor, those two will cancel. Yeah, this one you have to use L'Hopital's rule on. This was a bad example on my part, wasn't it? Because we still would end up with 0 over 0. If we use L'Hopital's rule, which is not a thing we can do in 3D, and I'll show you why, then we would end up with 2x plus 6 over 2x. So we would then end up with 12 over 6, which equals 2.
Couldn't we do, instead of L'Hopital's rule, couldn't we multiply the top and the bottom by 1 over x?
Multiply the top and the bottom. The bottom's still going to be 0, right?
Oh yeah, I see now.
Yeah, the bottom still, this is still going to be a 0 over 0 scenario. So from that standpoint, no, it's going to be undefined. All right, so let's talk now about what's going to happen when we're dealing with a limit in 3D. Okay, and we need to think about this. So I want to plant this seed in your head, for lack of a better term. All right, in 2D, right, if I've got a curve and I want to find the limit, right, on the curve, what did we do? We came from both directions. Remember doing that where we're coming from both directions? Now we're on a flat plane. So we're only going to come from the negative direction, 3 minus, right? And let's say this is at 3. And then we're going to look at it coming from the positive direction. So you're going to go back to Calc 1 and go, Calc 1 was kind of a nice experience because there were only 2 options. All right, the options were I'm coming in from the left or I'm coming in from the right. And what had to happen for the limit to exist?
The left and the right had to equal each other.
Excellent. The left and the right had to equal each other. Okay, so hopefully you remember this, but I want to make sure, I'm teaching this differently than my notes, which always makes me a little nervous, but I think the key is that we need to make sure, I need to make sure you understand that in 2D we came from 2 directions. In 3D, right, we can come in from any direction, can't we? All right, so when we're dealing with our 3D space, and then I'll write some math down, but when we're dealing with our 3D space, right, let's say we have some bizarro shape. Something like that. And let's say I want to know about this point on the shape, which is right here. Well, certainly I could come in like this, can't I? But think about it. I could come in like this, couldn't I? I could even come in like that, right? I could even come in coming straight in, straight down onto the screen. All right, so from that standpoint, what would need to happen? All of those would need to be true. All right, that's a little big sort of order to feel, so to speak. So the way we're going to handle it is we're going to break it into little bits. Now, we don't always have to break it into bits. All right, where we're going to need to break it into bits is when we're dealing with a 0 over 0 scenario. All right, this is the one that's going to get tricky. Okay, now, we don't always have a domain problem. Your homework seemed to be, where's my homework solution set? Seemed to be a domain problem happening a lot. Yes, it was. Okay, so I'm going to take it back a little step and let's just look at what's going to happen. And yes, see, I do my homework. Let's just look at what's going to happen, and then let's look at what's going to happen when we have a domain issue. And we're not going to get too far into these, but we can at least get started. So let's do one that's straightforward. Okay, so you can put down No, not necessarily. You can put down, this is where you're going to get yourselves in trouble. All right. If you're taking your exam and you just write does not exist and you don't show me the work to prove it, you're going to get 0 points. So be careful with that. All right. You're going to require me to, my requirement on this exam is you're going to show me the paths that you're using to determine this. All right, so let's go ahead then. And as I said, let's do one where we don't have a domain problem and things are straightforward. All right, so this is what it's going to look like. And by the way, let me give you the formal notation for it. Hang on, I've lost the formal notation. All right, you're going to see something like this. XY approaches AB, right, of f of x, comma, y, that then approaches L, or a limit. All right, in addition, we can have something that looks like this. X, Y, and Z. It can approach 3 numbers, A, B, and C. All right, that then can potentially give us a limit. All right, Perla, I agree with you. Math needs to be done on E2 paper. There's just no other way around it. Okay, so let's go ahead then and look at one of these that's straightforward, and let's look at one that's not straightforward. Okay, and once again, on your exam, you're gonna have to show me how to correctly go about doing this using different paths, because you can have different paths coming in. Let's do a straightforward one first. Oh, we don't want this. I'm not sure where that's coming from. Let's do a straightforward one first. All right, so here's an example. Let's say we have the limit of x, y, and z, and we're going to go to 2, 1, and -1. So this is then our function. All right. Do we have any domain problems with this? Looks good to me. I don't see any domain problems. Hannah, you have something you need to say?
No, I forgot that I was unmuted that entire time.
Oh, that's okay. Yeah, I was here. I thought I was hearing something in the back, but I wasn't sure. All right, so let's go ahead then. Now, since there are no domain issues, these are relatively straightforward. You can plug in. Okay, so if we plug it in, we're going to have 3 times 2 squared times -1, right? I'm plugging the 2 in for x, the -1 in for z, plus 1 times 2 cosine of 2 pi minus pi, and then this is a -1. All right, so this is then going to end up being a, let's see, that's going to be a 4. -12 plus 2 cosine of 3 pi, right? So that's going to end up being -12 3 pi. I have it as a -2, so this one would be -14. So let me make sure you guys catch up and make sure I did that cosine of 3 pi, right? Yeah, it's a negative 1. Okay. All right. These are nice and straightforward, aren't they? Okay, as I mentioned in the homework, they're not nearly as straightforward, and you need to be a little more careful with them. And you're going to have to show me your paths. Okay, and what do I mean by that? Now, I'm gonna kind of give you some rules of thumbs, because if you think about it, you have an infinite number coming into this one point in 3D. So, if we have a limit scenario where it equals 0 over 0. All right, you're going to want to check your paths. Okay, so the first one you're going to want to check. So here is our sort of our list of checks. All right. Check what's going on, and we'll start by checking what's going on the x-axis. Come on. On the x-axis, what happens? Well, y equals 0. So you then have the limit of x comma 0 of your function. Second, you can probably guess what I would tell you to do. That's to check the y-axis. When you're on the y-axis, x equals 0. So then the limit is going to be 0 comma y of f of x, y. And all this is allowing you to do is it's allowing you to take things, for lack of a better term, down to Calc 1. All we're doing is we're doing this sort of to simplify Calc 1. Okay, so I don't know if you're familiar with if-thens. All right, if these two are both true, you got to keep checking. You can't go, oh, I'm in good shape. You got to keep going. If one is like, let's say one is 0 and the other is 1/4, okay, you can stop. The minute you get two different numbers, you can stop. I would then recommend for the third one, oh gosh, I don't know. This guy's having a rough day. For the third one, we're going to set y equals to x. All right, so that's usually a good rule of thumb. So now we end up with the limit of x comma x. All right, the fourth one, y equals x squared. Now, you can keep going with this forever. Okay, I'm not expecting you on your exam to go forever. But I do expect you to show me at least these paths. Now, once you've hit two different numbers, you're good, man, right? You can wave goodbye. You can like, I'm done. I'm done with this. The fifth thing you have to do, if none of this works, the fifth one you're going to have to do is the squeeze theorem. Okay, so that would be sort of your last shot. Now, be careful about the does not exist, all right? Because thinking that they're all does not exist is not correct. All right, and that's why you're going to make sure that you have that squeeze theorem in your pocket. All right. Okay, let's do an easy one of these. We'll come back. We'll do some where we need to use the squeeze theorem. Well, let me know in the chat. Do we need a squeeze theorem review on Wednesday? Okay, so we'll do a squeeze theorem review on Wednesday. All right. Let's go ahead then and let's do one that, you know, is relatively straightforward when it comes to where we've got this 0 over 0 scenario. Okay, so if we take the, and we're probably going to run out of time, we might have to finish this up. All right, the limit as x and y approaches 0, 0, and let's say we have x squared times y squared, hello, divided by x to the 4th plus 3y to the 4th. Okay. Now, if you just put the zeros in there, you're going to see pretty quick, this is just going to become 0 over 0, which means what? We need to look at different paths. So, walk down the list. All right. Do not assume because it's 0 over 0, the answer is does not exist. All right. Okay. So let's go ahead and let's start off by saying I'm going to investigate. That's delightful. That's not what we want. I'm going to investigate the x-axis. And that's where y equals 0. All right, so what happens when we do that? We're then going to have the limit as x comma y approaches, but now it's not, and now it's going to be what? It's going to be x comma 0. So wherever I see a y, I'm going to put in a 0. All right, this ends up then being 0 over x to the 4th. As x goes to 0, we're still at 0 over 0. That did not help us much, did it? Okay. We're going to have the same problem with the y-axis. I'll tell you right now. All right, but let's go ahead. So to get full credit on your exam, you're also going to check out the y-axis. All right, you're going to end up with 0 over 0. And as I said, we will review Squeeze Theorem and I'll do some more of these. But let's go ahead and for this one, let's go ahead and we're going to try y equals x. Now we have the limit of x comma x. So we're going to end up then with an x cubed, right, times an x, because in every place I see a y, I'm going to put in an x over, is this the original problem we were dealing with? Sorry. Oh, that's squared. X squared, so it's going to be an x to the 5th. I must have skipped an example. Okay, and that's then going to be over on the bottom, we're then going to have x to the 4th plus 3x to the 4th. All right, let's see what's now going to happen with this.
Hold up, isn't the original x squared y squared all over x squared plus 3y to the fourth?
It's x to the fourth plus 3y to the fourth. All right.
The numerator is x squared y squared, correct?
Oh, okay. Oh, that's even better. Things will cancel. All right. So we're going to end up then with x to the fourth on the top. On the bottom, we're going to end up with 4x to the fourth. Right? And so this is then going to turn into 1/4. So the limit then, as for example, x goes to 0, since everything cancels, is then going to be 1/4. Okay. All right. Now, as I said, you need to get a second line. I am out of time. So you would put in y equals x squared. That's going to give us an x to the sixth over x to the fourth plus 3 x squared to the fourth. All right, that one's then going to go, that one's going to be another 0. All right, I have to go, so I'm going to have to end today's session. Please do your 14.1 homework and start your 14.2 homework.